Hello everyone, welcome to the 17th video of our Biopharmaceutics challenge, whereby today we are going to discuss the pH partition hypothesis. From the name it conveys us the two things. Number one is going to be the pH and second is going to be the partition. That means hereby we are going to explain how the ionization state of the drug will influence its distribution across the biological membrane. By far we already know how the drug ionization, drug pKa, based on its acid and basic nature, at what sites it needs to be absorbed, what must be the pKa value, the lipid solubility, and mainly the pH at the absorption site, how it affects it, right? So based on these three things only, we have designed our pH partition hypothesis. So let's see in parts and let's see what are the formulas that we need to see. Number one is going to be the assumption main, that is the pH partition hypothesis. Explain how the ionization state actually influences the absorption as well as the distribution of the drug from the towards across your biological membranes. That means you already know three criteria of a good absorption. Number one consideration will be your ionization based on the pKa profile. You already know if a drug has acidic strength and pKa. If a drug has a lower acid strength, then the pKa is little higher side. If a drug has higher pKa, that means the acidic strength is quite lower. So simple thing and vice versa. Second thing we have is the lipid solubility. So biological membrane, crossing the biological membrane, the molecule, if it is lipophilic in nature, its passage will be quite favored, right? It will be able to pass across the biological membrane because of the phenomena of like dissolve like concept, right? So it must be lipid soluble, uncharged, and pKa your and last will be your pH at the absorption site. So for your all knowledge, we know that the ionization and the lipid solubility are highly discussed, this ionization, with the Henderson-Hazelbach equation, right? I hope this is what you all know. So for a weak acid and weak base, we have different equations, right? For your weak acids, we have pH is equals to pKa plus log your ionized upon unionized fraction, right? Similarly, in the case of weak base, we have pKa plus log of unionized upon ionized fraction. These are the simple formulas based on your Henderson-Hazelbach equation. So we can calculate the percentage drug ionization. So these are important formulas for the calculation of percentage drug ionization. In case the drug is your weak acid in nature, that will be 10 pH minus pKa upon 1 plus 10 pH minus pKa. 1 plus 10 upon pH minus pKa. For the weak base, it will be little reverse. It will be 10 pKa minus pH upon 1 plus 10 pKa minus pH. So with the given values of their pKa and pH, we can get the ionization, percentage ionization of the drug, and we all know how the percentage ionization. So mostly the drugs exist with an equilibrium of ionized and unionized form. Generally, the non-ionized or unionized fractions are considered lipophilic, which will diffuse across the membrane quite highly. Then we have ionized fractions, which are more of the in the hydrophilic side, which will have certain limited permeability, which we all know, right? So the drug absorption, third thing is the absorption site pH. So based on your pH partition hypothesis, this is the relation where you can easily see a drug with a different pKa value is considered what and is ionized or unionized at what fraction. For example, Drug which is strongly acidic or strongly basic. Kindly see, a drug which is strongly acidic has a pKa less than 2.5, strongly basic with a pKa more than 11. These will be ionized at all pH values, right, in the GIT. Then you have weakly acidic drug 2.5 to 7.5 or weakly basic drug with a pK 0.5 to 11. Now these are relatively unionized at all pH values, right? Absorption generally occurs in the acidic conditions of the stomach. In case of base, these are basically ionized, unionized at all pH values, and absorption occurs relatively at the pH of your intestine. Okay. Then you have a very weakly acidic, which is to completely unionized at all, and a very weakly basic, which is also complete unionized at all pH values. So based on the pH values at different levels in the GIT, a drug based on its pKa, also its ionization and unionized state will vary. That will guarantee its absorption. That will leads to a good permeability if unionized, and at what will be the site of absorption. So this is all based on our major hypothesis, which is the pH partition hypothesis, which well explains this ionization in accordance to the drug distribution across the biological membrane. I hope you have understood the importance of the ionization values at the pH at the absorption site, as well as how the lipophilicity and hydrophilicity are different in terms of the drug absorption and crossing the biological membranes. Thank you so much. We'll meet in the next video.